All right, AP Environmental. This is Unit 7, Topics 7.2 and 7.3, which deal with the topics of photochemical smog and thermal inversions. So first we're going to talk about the term smog and what does it actually mean. I don't want us to get smog confused with the term fog. Smog is basically just reduced visibility, which, fog can cause that, a haze could cause that, but smog is caused by pollution. Okay. It's basically, imagine walking out of your house and it being kind of foggy, and you kind of being unable to breathe very well, all because there are pollutants in the air that are so heavy, and so dense that it has an impact on your health. Right? That's what smog is. Now, there's typically a couple different types of smog. The first one we call it gray smog. It's also known as London smog, and I'll kind of explain what that is in a second. But the main topic today is photochemical smog. It's also known as Los Angeles smog. The city of Los Angeles is kind of notorious for having this type of smog, but so are a lot of other big cities. But Los Angeles, again, it's just kind of the one that's kind of gets the bad rap, I suppose. Now, gray smog is pretty simple to understand. It's mainly caused by industrial pollution, and that's basically burning coal. So, for example, in this picture down here at the bottom, say you have a coal power plant. Especially, you see that. Well, the reason why they call it London is because 100 years ago or even earlier, when they first started burning coal, I mean, there was no real restrictions to it, and literally just black smoke would just billow out of these exhaust pipes, and if you lived near this, I mean, you would be breathing in all of these particulates and sulfur particles, and I mean, it's not good. Um, it still happens today in certain regions around the world, um, especially areas that have a very low elevation and they're surrounded by mountains. And China is kind of notorious for this. There's a video that I showed the other day, or I assigned the other day. And if you haven't watched it, it's all about China's air pollution problem. And part of China's air pollution problem, one, is that they burn a lot of coal. Um, and number two is they're just like just the geography of their country. It makes it real difficult for all of these particulates to escape into the atmosphere. Instead, they linger very close to the surface. That's what gray smog is. It's this industrial pollution that is produced from these smokestacks. Again, mainly in areas where there's a lot of coal burning, and we do see that in China quite a bit. This kind of brings up a good point here. I think this is a good time to bring this up. It's called a cap and trade system. A lot of countries around the world, especially in Europe, even certain states in our country, have really gone towards something called a cap and trade system when it comes to carbon emissions. Let's say, for example, that we in this picture here you have these two factories. Okay, let's just say that this is in, I don't know, some European country. It could be right here in the United States as well. But let's say that these two factories, let's say that they emit a total of 3,000 tons of carbon dioxide every year. Okay, that's combined together. You'll notice that one of the factories is a little bit smaller than the other one. So let's just say that this factory on the left produces 1,000 tons of carbon dioxide, and the factory on the right produces 2,000 tons. But again, collectively, they produce 3,000. Well, a lot of countries around the world have decided to do something about all of these carbon emissions. So what a lot of them have done, and the European Union is kind of notorious for this, is they've set up a cap. And they said, okay, we know that you're going to pollute, but we want you to pollute less. So we're going to set this cap up, and we're going to say, okay, you can't go over 2,700 tons of CO2 collectively. Okay, that's the total amount that you guys can produce. So, of course, what that would do, that would put pressure on the people that own these companies to produce less carbon emissions. So, we're going to ask this factory on the left, hey, can you produce 100 less tons per year? The factory on the right, since you're producing twice as much, we're going to ask you to produce 200 less tons per year. So, I mean, it kind of balances out that way. So, collectively, they can produce that 2,700. As long as they don't go over the cap, that's good. So let's say this is what happens. Let's say in the first year, let's say that the factory on the left, emits 700 tons of carbon dioxide. So they're under the cap, right? They're in fact they're 200 tons under the cap. Now the factory on the right, they produce 2,000 tons. So they are 200 tons over the cap. Now, a couple of things could happen here. This company on the right, this factory on the right, they can be fined heavily, for going over the cap. Maybe they can be shut down by the government, whatever. I mean, some drastic things could happen. But the factory on the left, they still have 200 more tons that they were under by 200 tons. So the trade of this is basically where the company or the factory that is under the cap, they can actually sell their emissions to another company. So this company on the right that was over, they're going to get fined, but I mean, they can just buy those emissions from another company. So that's why we call it cap and trade. You cap the emissions, and if one company is under and one company is over, that's okay. One company can sell their emissions to another company because they didn't use all of it. So it's kind of an interesting way that things are set up, but it actually does work to help keep these companies under the cap. I mean, if you think about it, even though this company on the left sold, 200 tons of carbon emissions to the other one, they still stayed under their cap, collectively as a group. So that's kind of a good thing. It really, I think, has some benefits, and I think a lot of governments are sort of looking at that. So it's kind of an interesting way to look at carbon emissions. All right, now photochemical smog is the other type of smog that I want to mention today. And the reason why I think this one is important is because of the actual pollution aspect of it and how it actually forms. Now, photochemical smog is a mixture of a couple of different things. It's a mixture of different types of pollutants, and I'll show you these things in a minute. But they're formed anytime nitrogen oxides, remember those are NOx compounds that we talked about previously, and something called volatile organics or volatile organic compounds are also known as VOCs. I'll explain what those are on the next slide. When these things react in the presence of sunlight, you can get photochemical smog. Now, there's some chemistry behind this, so I really need you to kind of pay attention here because this can get a little tricky if you don't really understand some of the chemistry behind it. Let's take a look here first at what the term volatile organic compounds are, or we call them VOCs. Volatiles are basically, they're just organic compounds that can vaporize. That means they can, turn into a gas at room temperature. So it doesn't have to really be warm, doesn't have to be, real hot outside. These things at just regular room temperature, they can form toxic fumes that can go up into the atmosphere. I always tell kids, think about smelly chemicals, gasoline, paint, a lot of your household chemicals, most of those things contain volatile organics. Probably the biggest one to remember is gasoline. Okay. There are some natural things though as well, like for example, conifer trees, like pine trees, for example, that pine scent, that's actually a natural volatile organic. So that's a natural compound that goes up into the air. But again, a lot of these things are just man-made chemicals, like aerosols and air fresheners and things like that. That can vaporize and go up into the atmosphere. All right. So as far as the process goes, how does photochemical smog um, start? How does it form? There's a couple of different um, pictures here that I kind of want to show you. And if you're at home and you do have the fill-in notes, you might want to write some of this stuff down because again, this can be a little bit tricky. So we're going to start over here on the left. So one of the things that's kind of important to remember is the time of day. Okay, so let's just say, for example, I don't know, on a Tuesday morning or whatever. Let's say that this is in an urban area. Let's say it's like a city, or it could even be Crown Point, wherever. Um, but during the daytime, there's a lot of traffic on the roads, right? A lot of cars are driving around, and one of the things that those cars produce is NO2, right? That NOx compound, that's something that's produced anytime we burn gasoline. So if you think about like an urban area, there's lots and lots of transportation, lots of vehicles. During the daytime, there's a tremendous amount of this NO2 that gets produced. There's some anthropogenic things that could cause that as well, but I mean or I should say there's some natural things that could cause that as well, but the anthropogenic thing is automobile emissions. So a ton of that goes up into the air. Now, take a look at what happens to this NO2 once it's in the air. It's going to react in the presence of sunlight. And what the sunlight does is basically the ultraviolet radiation from the sun. It actually breaks the bonds of NO2 and it creates these two things. All right, one of them is nitrogen monoxide, it's another NOx compound, and also an oxygen atom. Now, this oxygen atom doesn't like to be by itself. It like needs to bond to something like right away. So what that oxygen atom is going to bond to is an oxygen molecule that's already in the air. O2 is that's in our atmosphere already. That's what we breathe in, right? So when that happens, we get ozone. This is tropospheric ozone. This is the stuff that I talked about last week. So during the daytime, especially in urban areas, we get a constant buildup of this tropospheric ozone during the day. And usually by mid to late afternoon, that ozone is going to be at its peak as far as forming in the atmosphere, forming in that tropospheric layer closest to the Earth. So I need you guys to understand this reaction here. All right, how does NO2 get into the air? What happens to it when it's in the air, right, during the daytime? And eventually, what does it form? Okay. Now, you'll notice this picture on the bottom. Now we're at nighttime. So our sun is, disappearing. It's disappearing over the horizon. But at nighttime, I want you to kind of notice what happens. So this ozone here, that formed, this is the same ozone that formed at night or that formed during the daytime. This ozone now is going to go through a chemical reaction as well. So what that ozone is going to do is going to react with the nitrogen monoxide that was formed up here. Remember this stuff that was formed during that reaction when sunlight reacted with NO2. So when this reaction takes place here, take a look at the products. We get oxygen gas, and we also get NO2. So really, if you look at this bottom reaction, this is basically the exact opposite of what's happening up here. So during the daytime, NO2 is going into the air and producing ozone. But at nighttime, that ozone is breaking down into NO2. So this is just a nice balance. It's a nice steady state, right? Ozone is being built up, and then ozone is being broken down. It's being built up, and every day it's this up and down, right? I mean, maybe you've heard of like ozone action days, they call them. A lot of times that'll happen, in the middle of the summer, especially when there's a lot of vehicles on the road. It's a nice, warm, sunny day, and you get a lot of that ozone that builds up during the day, and that can be dangerous because this is a lung irritant. You don't want to breathe it in, but at nighttime, it's going to break down naturally. Okay, at least that's what's supposed to happen. So again, what could possibly go wrong, right? I mean, what is it that's so bad about this? Well, here's the problem. All right. Take a look again on the left. All right, we have our NO2, right? So we're back during the daytime, right? So we have our NO2, and then that's breaking down, and then forming our ozone. So this top area right here, this top reaction, is what normally happens during the day, right? Our NO2 is put up into the air, and eventually it turns into ozone. That happens every day. And then at nighttime, it will break down. But there's an issue. And the issue is these VOCs chemicals. All the gasoline that's spilled on the road, all of the open paint containers and all the chemicals that we use, those VOCs compounds can actually react with nitrogen monoxide. Now, this nitrogen monoxide, you have to remember where it comes from, right? This stuff is going to be used to break down the ozone at night. So now, instead of it, eventually breaking down the ozone, it's going to react with those VOCs compounds, and it's going to create something called PANS. Now, PANS are a group of chemicals that are not good. These are things that, again, you don't want to breathe in. They're things that can cause skin cancer. And that's actually what photochemical smog is. Photochemical smog is basically this collection of not only ozone, this stuff's not going to be broken down at night now because of this nitrogen monoxide is now being used up during the day, but it's all that ozone mixed with all those PANS, all those photochemical oxidants that can be very unhealthy. So, I mean, this can be a really big issue if you live near a big city and this photochemical smog is constantly building up. So here's kind of what I want you to remember, chemically about this set of reactions. I'm going to go through this with you. There's 5 different things that you need to know, and you need to make sure you study the chemistry of this. So again, oops, what happened there? There we go. So again, our first reaction is basically how does that NO2 get into the atmosphere in the first place? It says here the heat of combustion from car engines, furnaces, and power plants can form NO2. So this is how the NO2 gets into the air in the first place. Again, I think the big culprit here is automobile engines. That's kind of but there's some other things as well that can put it up there. So, when nitrogen reacts with oxygen, you're going to get NO2. This is how it gets into the air first. Now, once it's in the air, we said earlier that it can react with ultraviolet light. And when it does that, it breaks down or it decomposes into 2 things, right? Nitrogen monoxide and also oxygen. Now, that oxygen is now free to bond with oxygen gas, which is already in the air, and it can form ozone. So these first 3 reactions, this is just what normally happens during the day. All right, of course, the more automobiles there are, the more this is going to happen. If you live in a rural area where there's not a lot of cars, then this probably is going to be very limited. But if you live in an urban area, this will probably be maximized. Now, eventually at nighttime, that ozone is going to react with nitrogen monoxide that was formed during the day. And it'll break apart to form NO2 and oxygen. So this is our normal nighttime reaction. So if you look at these previous two reactions here, right, we have the buildup of ozone, we have the breakdown of ozone, basically, okay, or how it builds up and how it gets removed from the atmosphere. But of course, what's going on now is those VOCs chemicals are reacting with nitrogen monoxide to produce those PANS. And those PANS are things, again, that we don't want to be breathing in. They can have impacts on plants, they can have impacts on humans. These are bad chemicals. It stands for peroxyacetyl nitrates. Probably don't have to remember that, but just kind of recognize this term PANS. All right, guys, I'm going to stop this video here today. I'll pick up with part number 2 in the next video. All right, guys, have a good day. Thanks.